Alrighty, in this section, what we're going to do is we are going to learn about the this keyword in JavaScript. So the this keyword really starts to come into play when we work with JavaScript objects, sort of JavaScript object orientation. And we're not going to talk about prototypal inheritance quite yet. That's actually the topic of the next section. But before we do that, before we sit down and talk about creating objects and pseudo classes and inheritance, all that fun stuff, we really need to understand the this keyword and what it means and how it works. And it's funny because this keyword often causes a lot of confusion, but it actually follows some very simple rules. So in this video, I'm going to describe some of those rules, show you guys somewhat how to manipulate the this keyword. And then the rest of the section is going to be about things like call, apply, bind, arrow functions, and some new ES 2006 or 2017 syntax. I think that's going to be standardized next year that we can use to manipulate the concept of this. So let's go ahead and just first do something fun right now. I'm going to go ahead and write function. Example 1. By the way, I did write a new HTML file and a new JS file. I don't need this. I'll leave that people list in case we need it. And then a new JavaScript file. And I'm now pointing to that new JavaScript file over there on the left. Okay, so example 1. Let's do console log this. And let's run example 1. What do you think the output is going to be? So we've seen I'm sure you've seen this keyword used before, but let's go ahead and see what happens when we just log it out straight out of a function. We might even be able to do this as well and see if there's going to be any differences. So what do you think the output's going to be here? Let's hit Control S, and what we get is a window object. So we immediately see that inside of that function, as well as outside of the function, this keyword is pointing to the window object, the global scope. I want to point out that in strict mode, you will get undefined here, but that's irrelevant. The point is right now, this keyword is pointing to the window object. So that isn't always going to be so useful. So let's go ahead and see some actual useful instances of this keyword. And I'm going to show this example by creating a JavaScript object. And you guys should be familiar with JavaScript objects. JavaScript objects are just objects, just bags of properties, right? So I can say var person, and then I open up a JSON notation here. Now again, I'm not writing constructor functions where we use the new keyword yet. That's going to be something we're going to do in the next section. But for now, we'll do an object, and then we'll give it a name of Nelson, and we'll give it a function. To write a function on a JavaScript object, we can say something like print this is function, and for here we'll do console log this, and then we'll simply do person.print this. So the person is an object. It contains data and functionality. In this case, it contains a property, a string property, Nelson, and a function of simply returning this. If you so let's go ahead and hit Control S, and what do we get? We get object named Nelson, meaning this object, this right here, is pointing to basically this object right here. Be this exact same thing if we had console logged out person. So in fact, we can do this.name to get Nelson out of that. So as you see, this keyword here is referencing that object. But the funny thing about how functions work is that this keyword won't always necessarily point to the object that it was defined on. Unlike statically scoped variables that are bound at runtime, or bound at compile time, this keyword is bound not at compile time but at runtime, and it can change and it can cause a lot of confusion. So let's talk about how some of the confusion that you might run into with using this keyword. So let's go ahead and comment this out. I just wanted to establish this syntax here, which I'm sure you guys have all seen and familiar with. So let's go ahead and do an example 2, and I'm actually going to go ahead and create a button on our HTML page. So I'm going to come over here. I'll delete people list. I'm going to create a button with an ID of, I don't know, button-1, and then the text will be press me or something, right? So we now have a button on our HTML page that we can reference from within JavaScript. So I'll close that out. Again, all it is a simple button with an ID. So what I'm going to do here is I'm going to say var button equals document get element by ID button dash 1, and then I'll do our classic button add event listener, passing in click for the event, and then passing in a callback here. So let's go ahead and do console log this. So now when I click on this button's click handler, what do you think the output of this would be? Now it's interesting because this keyword here isn't being it isn't a part of an object, right? So this keyword over here in print this was part of an object, and when we did console log this, we got the object that function was a part of. Whereas in here, this function is not part of an object, but when we do console log this, we got the window object, the global object, or undefined if we were in strict mode. So this is interesting. What do you think the output would be? This is a function that's not whatsoever attached to an object. It's just a closure or a callback function that we passed in as a parameter. So let's go ahead and press the button, see what happens. Press the button, and bam. As you see, the object we got back was a DOM element pointing to that button. That was what this is. In fact, we can even manipulate the button's text. I can say this inner text equals I don't know, I was clicked or something, right? And I can save that, I can press me, and it says I was clicked. So we have some interesting things here. We have three sort of cases already up on the screen of different behaviors of this keyword that you might not have considered before. But as we're going to find out in this section, the behavior is actually consistent. It follows a couple of rules. But again, just to recap, we have a function passed in as a callback where this is somehow assigned. Somehow that happened. We'll see how that happened later. We've seen an example of a function attached to an object where this pointing to that object, and we've seen an example of just a function straight up called. So yeah, what I'm going to do, I'm going to take this line of code, I'm going to put it up here. I'm going to leave, with all our examples, I'll be commenting out the examples as we go along, but I'm going to leave this var button equals document get element ID so I don't have to rewrite that for anything that works with the button. Now, let's go ahead and go to example 3. Let's kind of combine the two. Let's see if we can't get a reference to this added to be an object when we add an event listener to a button. So we'll do example 3. And I'm going to do this a little bit differently. I'm going to say var person equals empty object, person.name equals Nelson, and then I'm going to say person dot print name equals function console log this dot name. So I'm just showing a little bit of a different syntax. This actually is for all intents and purposes, this syntax right here is identical to this more compact syntax here. I just want people to get used to the fact that when you create an object with JSON notation using the curly braces, there's actually really no difference between doing that or doing it like this, where we create an empty object and then we add properties onto that object. Physically no difference. I can prove that by doing person.printName and running this, and we'll see Nelson printed out to the screen. But what if I wanted this function right here to be invoked when I click the button? So you might do something like this. You might have done something like this in the past and been confused as to why it didn't work. So we'll do click, and then we'll do person.printName. So we're passing in a function that is attached to an object into the click handler, right? So this is another way. So again, just to recap, straight up naked function, this was the global object. Function part of an object, this was the object. Callback with a just straight up function, it was the element that was clicked. So think about for a sec, what do you think this is going to be in this case? And I'm saying this a lot because, that's an English word that you tend to use a lot, so apologize for the ambiguity. English is a fantastic language, I know. So this print name is this function right here, which is attached to an object. So let's go ahead and hit press me. And what we get right here is blank. Actually, a better way to do this would be to say person.firstname and then this.firstname. That'll probably give me the result I want here. Okay, there we go. When I hit press me, I get undefined, so that's weird, right? So we need to figure out what the this is. Now, there's a couple ways we can figure out what the this is. I could, of course, do a console log right here, or I can pop open the debugger, which is something that I encourage people to get really used to doing, popping open the debugger to figure things out. So I'll go ahead and put a breakpoint here, which will prove that this method that we wrote on this object is indeed being invoked when I click this button. So I have a breakpoint. Execution will pause when I click this, right? So I press this button, execution is paused. Now, if I go into scope, remember how we have the local thing? We've already looked at the scope window, where the scope window shows all of the captured variables from lexical scopes that are higher up, right? So I have the local scope, and we have the this variable, but if we look at the this variable right here, what is it? It's the button. So when we passed in person.printName as a callback to the click handler of the button, when it gets invoked, the this is not the object that had that method on it or had that function on it. The this is the button. So that's why we're getting undefined, obviously, because the button has no property called first name. It's a completely different object. So this is kind of weird, and it's actually a bit different, especially if you have a background in like C#, where if you were to add an event handler, it captures both the object and the method. So this is definitely a bit of some curious behavior, I'd think, because it seems like the rules are being broken, right? The rule earlier was when we invoked the method on the object, this is the object that the method was defined on. And but when we did a callback, this was the button. And so we're starting to kind of get an understanding of what this really means in JavaScript. And what it means, and what you'll hear it referred to as in documentation and Stack Overflow answers and all that stuff, is the context. So what, or rather, this is a part of your what's called the execution context. And the funny thing about this is, as we've demonstrated so far in this video, the execution context, and particularly the this binding, can be different depending on how the method is invoked or how the function is invoked. Apologies if I say method instead of function for people who, like for example, in C++, a function is a function that sits outside of a class, whereas a method is one that's inside of it. For languages like C# or Java, they only have methods. Methods are attached to classes, and in JavaScript, JavaScript doesn't have classes, so you have functions. Generally speaking, I'm just so used to saying the word method if it's involving an object. But if I say method, I'm also meaning function and vice versa, because JavaScript doesn't really have the concept of a method. But like I would call print name a method, but I might call example1 a function, even though they're in JavaScript, they're both technically functions. Anyway. So it has some interesting behavior that we've seen, that this binding changes depending on how the function's called. And what's interesting is that functions are really just values in JavaScript, and we've discussed that already. Functions are values. Functions can be passed around. They can be manipulated. You can invoke methods on functions. Functions actually have methods and properties that we can invoke. I mean, if you don't believe me, I can come over here and type in or inspect in my sources watch window. I can go ahead and add a new watch for person, open up the object, and we have this print name, which is a function, but functions have methods and properties on it. Like, look at these properties: arguments, caller, length, name. Then they have our scope, which is data attached to it. Then they have a prototype, which is a function, and its proto has a bunch of other things, such as constructor, is prototype of, toString, so on and so on. So the thing I'm trying to say here is functions are just variables, but they're variables that contain functionality, hence the name function. And this is different from a lot of languages, particularly a language like C, for example, where functions, you would more rather call them just procedures, rather. But so stuff and things, they're just values. And what's interesting here, so we have person.printName. Let's look at another example here. So I'm going to say var print name, or how about do thing, so I don't get confusion with the naming of my variables, equals person.printName. And so this is completely valid. I've gone ahead and I've extracted the print name function out of person, because again, a function is just a value, and we can stuff it in variables. So what do you think the output will be if I do thing right here? Just invoke do thing. Now remember, do thing comes from the person object, right? We've extracted it out there. But what do you think will happen here? So let's go ahead and hit Control S and see what happens. We get undefined. Why do we get undefined? Well, let's go ahead and console log out this. Now I could go ahead and also I'll do a do thing, and then I'll also do person.printName. I'll do both of them. So remember, do thing points to that same function that we're invoking here. So let's hit Control S and see what happens. So the first do thing is called, which calls print name, which logs out this.firstName and this. And the this.firstName is undefined, and the this is the window object, the global global execution context here. Again, in strict mode, that would also be undefined. The second invocation, though, when I do person.printName is Nelson, followed by the this, which is an object. So I hope we're starting to understand here that this keyword, in stark contrast to how scoping works. Scoping is all determined statically at compile time. But that this keyword is determined based off of how you invoke a method or a function. You can have the same function and you can invoke it 10 million different ways. And you'll get 10 million different this variables, right? Let's prove that. Let's go ahead and I'm going to go ahead and nuke these two guys. And then I'm going to go ahead and say var person2 equals empty. Well, let's not make an empty object. Let's give him a first name of foo, right? This is person2. Then I'm going to say person2 dot print name equals person dot print name. Then I'm going to say person2 dot print name. And let's run this function. And we see, when we do person.printName, we get our Nelson, followed by an object with the first name of Nelson. When we do our second print name, however, we get a name of foo. And it's important to understand that the names of the functions I'm using is irrelevant. I can add last name Baz here, and I can also, instead of doing person2.printName equals person.printName, I can do person2.do many things, and then I can invoke person2.toManyThings. I can hit save, and you see the same behavior. Basically, we get the this. Remember, and this is really what I'm trying to drive home here, is that there's only one function. This isn't like a closure where we're making 10 million functions every time we invoke a function, and an inner function is a closure, and a new scope is created, and there's a scope chain, and all that stuff like we talked about in the last section. There's literally only one function being created here in memory. But we're invoking it in 3 different ways. The first way we're invoking it is by adding it as an event listener. And of course, when we do that, we get undefined because the this is the button. When we invoke the method straight up by invoking it on the original object that was created, we get the appropriate value. But then when we attach that function to another object and then invoke that function through that object, we get a completely different result. And that's because this variable, this keyword, is determined by who is invoking the function and how the function is invoked. So yeah, this example shows 3 different ways that we can invoke the exact same function. Again, it truly really is the exact same function. I'm not lying to you. There's only one function allocated in memory when we execute this code. So in the next video, we'll continue this with some more examples. And really, the best way to explain this to you guys is just going through examples and showing you guys just the different behaviors that we can get from this keyword. And it does get very confusing, but hopefully we can start to clear them up with writing some more examples. And we'll see you guys in the next video.